blood tests, and then this week we're doing the immune system. So on Thursday, we don't have a lab, so there's a bit of lecture. Try to give you some breaks. We do have a lab quiz again, though, over today's histology and models. Kind of similar to what we did with the endocrine system. We looked at basic models. Today it's the spleen and appendix and our lymph nodes, and a little bit more of the histology as far as our lab activities concerned. Our quiz today is on blood cells, very similar to what I showed you on the previous one. Blood typing, blood cells, some of the material instruments we use for testing blood. So the lymphatic system has very close connections with the cardiovascular system as far as vessels are concerned. So our lymphatic vessels actually look like venules. If you recall, the venules have postcapillary venules have smooth muscle, but venules not a small amount. They're still very thin, and you won't be able to tell in histology image whether you're looking at a venule or a vein, except that a venule will have red blood cells. Okay. Lymphatic vessel will have white blood cells. Other cells that might have picked up, but it's not going to have any red blood cells. Okay, so it's more of a negative. So it's not a lymphatic, but you can't tell that it's the difference between a vein and lymphatic. So lymphatics are even lower pressure than our cardiovascular system because they form a backup. So they contain fluid from the vessels that wasn't under enough pressure to move back across the capillaries. So you probably recall me diagramming when we were talking about blood protein. I diagrammed a simplistic illustration of our capillary bed when we were talking about albumin and the role of albumin in maintaining blood osmotic pressure. And so we have the arterial side of our capillary bed and the venous side of our capillary bed. And if you recall, hydrostatic pressure or blood pressure was higher on this end because the arterial side of the capillary bed is closer to the heart, right? Farther away we move from the heart. Blood flowing downstream, down pressure gradient, so it's going to be moving farther away when we get to the other side of the capillary bed. We have a lower hydrostatic pressure or osmotic pressure. And also because of a hydrostatic pressure, we're going to be losing some fluid across the capillary wall. We talked about this in reference to systemic edema and even without any heart disease, blood pressure is going to push fluid across the capillary wall. In addition to the blood pressure, we have osmotic pressure due to the presence of albumin. And that was one of the plasma proteins synthesized by the liver. Remember, spelled with an I, not an E, because it's not the A protein that we're talking about. And the numbers don't change, but the concentration increases. So we have a lower osmotic pressure from the albumin on the arterial side than we do on the venous side because our concentration of the albumin has increased. Since we lose fluid, there's more albumin per volume. Again, we haven't increased the actual amount of albumin, the actual number of molecules, but it's just a higher concentration due to the degree of leakage. So with that combination, with a higher hydrostatic pressure and a lower osmotic pressure, we lose fluids on the arterial end of the capillary. And then with a lower hydrostatic pressure being farther away from the heart and a higher osmotic pressure because of a greater concentration of albumin, we gain some amount of water back. But not all of it, all right? So we're left with an increased amount of fluid, which if allowed to continue would lead to edema. So the purpose of the lymphatic system is a couple of fold. We have the vessels involved here as a means of returning this excess fluid, what has returned to the cardiovascular system back to the heart. And so again, I said this fluid out here is under lower pressure because it's been pushed across, it can't push itself back in, all right? So it went from a high to a low pressure to exit the capillary wall, so it's not going to return from low to high without that occurring. And so we have a system of lymphatic capillaries. And the lymphatic capillaries are structured such that they will increase the space between the simple squamous cells forming their wall. That's all we have is the simple squamous epithelia. And as fluid increases in the extracellular matrix, the spaces between these walls open up. So we have a simple squamous epithelium, and overlapping it, more simple squamous epithelia. And you can see that I have not drawn any type of junctions between these cells, okay? They do have some fibrous proteins holding them together, but as this pressure out here increases, these gaps open up. And so the fluid then from the capillary system can move into the lymphatic capillary, okay? And obviously out in the tissue, it's a higher pressure than it is in the heart still, so it's going to follow in a parallel pathway to the veins. So this is identified as a lymphatic capillary. It's called blind ending, so it's not connected like we have the blood capillaries here, are connected between the arterioles and the venules. These have no ongoing connection. Right? So this is a closed system for the blood capillaries, whereas the lymphatic capillaries are an open system. Fluid can move in and out. Right? So in addition to fluid, the water, and dissolved proteins that are in the connective tissue. We can have white blood cells because we find white blood cells in the loose irregular connective tissue. All right. Pathogens. So if this is close to the surface of an organ or body wall or lining of an organ, you can have bacteria or viruses. And we definitely don't want to return those two components into the blood, which is considered to be sterile. Okay? So along the way, lymphatic fluid is transported through a series of filtration structures that we call lymph nodes, where it's exposed to macrophages and to lymphocytes, which can degrade them and break them down and attack further ones that they might be outside the body. One thing we do not find, as I just mentioned, in the lymphatic fluid is that there are no red blood cells. And it's not part of the normal system. That would be the answer to a question, followed by the caveat that if there is a bleed, someone has thrombocytopenia and they have a torn blood vessel, and there's a lot of leakage, then obviously red blood cells would have access. It's not a normal component to find within a lymphatic vessel. Then as the lymphatic capillaries flow together, they form larger vessels that we call lymphatics. Okay? So we have lymphatic vessels that are throughout the body tissue and body organs. And the flow is towards the heart, so they have valves. And the larger ones, as they get closer to the center, are called lymphatic trunks. And you have some of these that are listed in your lecture notes, but I'm not going to hold you responsible for identifying them for lab. It's just kind of organization. We don't call them veins. Okay, so we just go from lymphatic capillaries to lymphatic vessels to trunks. And then finally we end up with two larger structures called ducts that will carry the lymphatic fluid specifically back to the subclavian vein. All right, so here's some characteristics of lymphatic capillaries. While you're jotting that down, if you don't have your PowerPoints with you, may I erase the board? You have the concept up there. And I'm going to talk a little bit about a lacteal. Okay, that's lymphatic lymphatic capillaries that we find specifically in the small intestine. So we have a couple of tissue models, histology models of the small intestine wall. And we'll come back to these in quite a bit of discussion when we cover the digestive system the last 2 or 3 weeks of the semester. And so this is looking at the lumen of the small intestine. Would be where my hand is. That's where the food is being digested. And we have these villi, not microvilli, but villi. These can be detected with a microscope. And they're covered with simple columnar epithelia. And inside each of them are the capillaries of the cardiovascular system. And so here's where we would absorb the material we talked about that was in the content of our superior mesenteric vein. So amino acids and simple sugars. And I don't know if you noticed, but I never mentioned lipids. Okay? Lipids are nonpolar covalent molecules, so they're not going to mix well with the water of our blood. And so for them to be soluble in the blood, in the plasma, we coat them with proteins. You've probably heard of LDL and VLDL and so on. All right? So when we coat them with proteins, and they become chylomicrons, we'll use that term when we get to the digestive system, they become too large to move into the blood capillaries. So we have instead single lymphatic capillaries in each of these villi. So here's the model I just showed you. And this green structure right here is the single lymphatic capillary. So our blood capillaries are going to have the arterial flow coming in and form a capillary bed and then leave as the venous flow. Remember, I just drew the lymphatic capillary as a blind ending. Okay? So the blind ending origin, I guess blind origin at the beginning might be a better term, starts up there at the tip, and lipids are transported into that. So we can have a lipid, triglycerides or cholesterol, coated by a protein, and the protein is placed around this while it's inside the surface cell covering the villi, and that can then pass into the lacteal. All right? So lacteals then are going to carry that fluid to the heart. And then when we talk about our liver, the portal vein has a high concentration of simple sugars and amino acids. And the hepatic artery that we said traveled into the liver with the portal vein is going to have oxygen and lipids. Okay, so they're both carrying content nutrients into the liver.
Yeah. The lacteal is the lymphatic capillary in the intestinal.
Yes,
Okay.
just a special term for the lymphatic located in that region. So as you can see in the upper diagram, these lymphatics travel with the small veins and arteries. And again, if you see it in the tissue, in a histology, you would only be able to say it wasn't a lacteal if it had red blood cells in it, and it may be either a venule or a vein or a lymphatic if it didn't have any. So it's just kind of a guessing game for that aspect of it. All right, so we're going to talk about the ducts. We have 2 sets of ducts that actually transport the fluid directly into the lymphatic system. So we've been going from the lymphatic capillaries, the lymphatics, to the trunks, periodically passing through lymph nodes. And now the lymphatic fluid is as filtered as it's going to get. Any opportunity for removing pathogens from the lymphatic fluid has occurred. And now it's ready to be transported into the blood system. And we have this asynchronous pattern of drainage. So I'll erase this diagram on the board finally, and we'll diagram the lymphatic ducts. So this is returning to the heart, so it's going to be going into veins. And it enters into the subclavian vein on the right side and the left side, just in between the internal jugular and external jugular. Okay, so we essentially right at the base of the internal just before it becomes brachiocephalic. So if I draw that, actually it goes into the subclavian just before the internal jugular joins it. So here's our internal jugular, and this is subclavian, all right? So coming up from just below the diaphragm, we have a large collecting chamber. It's found anterior to the vertebral bodies. And lymphatics from the abdominal wall are going to be draining into it from the organs. And this is known as the cisterna chyli. Chyli means bladder, so chyli, we use that term when we talk about the gallbladder. So this is a receiving chamber for all the lymphatic fluid from the lower limbs. Start from the bottom and add up. So from lower limbs, pelvis, abdomen, and that includes both the wall and the organs, right? And that's going to go into the cisterna chyli. And that forms what's known as the thoracic duct. The thoracic duct travels on the vertebral bodies in between the azygous and hemiazygous veins. Probably move this over just a wee bit, but because this is more going to be anterior, right in the middle, sorry, to the right, because it's draining into the right side of the heart. And it comes and empties into the superior, the subclavian. So this is identified as the thoracic duct, and it's draining into subclavian vein. Right up here is going to be receiving lymphatics from the right side of the head, right upper extremity, sorry, left side of the head, left upper extremity, and left chest. So you can see that asynchronous drainage here. All right, so everything in dark green is going to empty into the left subclavian via the thoracic duct. I have no idea why it's so unbalanced, all right, as far as the drainage area. The right thoracic duct is only about 1.5 inches, or rather 1/2 inch to 1 inch in length. And it's going to receive the right side of the head, the right upper extremity, and the right side of the chest. And this is known as the right thoracic duct. The right side of the head, right upper extremity, and right chest. So nothing from the lower extremity and nothing from the abdomen or pelvis. Okay. So I told the class last night, I almost told you guys this when we were talking about the azygos, but I had enough patience to wait. But when I was teaching at the med school, there had 3 or 4 midterms. They only had 9 weeks of class for gross anatomy, so they had about 3 tests and then a final. And they were mostly multiple choice, but there were 2 essay questions for every exam that they could choose one of. And we would spread out who was grading. So I was grading this one exam. It was taken by a student who was his 2nd attempt at med school. Once you get into med school, unlike dental school or graduate backwards to try to keep you in there, because they put in a lot of financial effort and so on. So it was the second time. And these were supposed to be full sentence essay questions. And no tables and charts and stuff like that. So he started out his essay saying, in the thoracic cavity there are 5 birds. Birds. This is how their instructor had described the content when he was talking about the respiratory system. There is the azygoos, the hemiazygoos, the accessory hemiazygoos, the thoracic duct, and the right lymphatic duct. And that was my reaction, like, huh? They're no longer birds. That might have been a good memory thing, but that's not what we call them anymore. So, but at this point now, the lymphatic fluid is considered, so please don't answer that on a question. The lymphatic fluid is considered to be filtered. All right, so we'll talk about the structure of the lymph node as part of that filtration
At what
component.
point is it filtered?
Once it's in the thoracic duct, or the right lymphatic duct. Because at that point, there's no more lymph nodes. So we have no lymph nodes along the thoracic duct, and the right lymphatic duct is just short, too short for that aspect.
So on the board, you have it written right thoracic duct, is that
I'm
right?
sorry, that should be lymphatic.
Okay.
All right, so first question, we have 5 tonight. So identify this white blood cell so you can answer the questions about it. And when I say it's phagocytic, that could apply either to the cell or to what it changes to as it matures.
Is that just another name for it, or just, that's another name you wanna say?
Not
But phagocytic, that's another name for wanna say? Or is it different?
Not if I added extra spaces here and put the little mark, so recognize the word, whether A is a separate part of it. Okay, you should have at least 2 correct answers. That's what makes it antibodies. That's what it looks like, a boiled egg with an eccentric nucleus. May I raise the whiteboard? You guys are looking at me. Pardon? Sorry? Number 2, a sample of blood contains A and B and D antibodies. What would be the blood type? Or what is the blood type?
No, it has to be possible because it has to be antibodies.
Or it happens on exams, right? Auto formats.
I guess so. Yeah.
What does the D antibodies mean?
If it's plus.
While you're looking at that, we have 2 of these models that hang under the bulletin board in the back.
It means it's negative.
I don't know why the rest of the muscle tissue is so orangey, but the white lines show the lymphatics, trust. All the little yellow dots are the lymph nodes, all right? And so you can see, it's a big model to not show very much. Because really the most important material, well, you can see the clusters of lymph nodes that occur in the axillary and the cervical regions and the inguinal regions. So where we tend to have joints and organ clusters, we see clusters of lymph nodes, and those clusters are named. So we have cervical lymph nodes and axillary lymph nodes and so on, all right? And then hidden here is the cisterna chyli, forming the thoracic duct. And then the right lymphatic duct is this short little piece right up here. Okay, so like I said, it's a lot of model, a lot of plastic for those 2 components other than the regional distribution of the lymph nodes. You done with question 2? Okay. So when we talk about the lymphatic system, we use a lot of our blood cells that we've talked about already. So the primary functional cell of a lymphatic system is the lymphocyte. And as we'll see on Thursday, we have 2 different types of lymphocytes. We have T cells and B cells, and B cells are the ones we've been talking about that make plasma cells, right? They become plasma cells as they're making the antibodies. They increase their amount of cytoplasm so they can have increased ribosomal ER and Golgi apparatus. So their specific functions we'll talk about on Thursday, as they provide cell-mediated immunity and humoral immunity. Why do you think we have macrophages in there as part of the lymphatic system? Pardon? No eating? Why is that important to the lymphatic system? Anybody have micro? Okay, so this is a specific or a non-specific activity when we utilize lymphocytes. Macrophages are non-specific, but B cells and T cells are specific. So they provide a specific immune response, meaning they have to recognize the antigens that are involved. So what's the role in macrophages? If they're non-specific, what's their role in a specific immune system? I'm looking for one word that starts with the letter, there's 2 words actually. APC, 3, okay. Anybody know what APC stands for? Yes, antigen presenting cells. That's the role of the macrophage. Because yes, it does internalize the pathogen. It will take the bacteria or the virus and phagocytose it, break it down with its lysosomal enzymes, and then as we'll see on Thursday, it presents it on its surface on special proteins, MHC proteins, that then allows the T cells or the B cells to be exposed to small components to determine whether or not they have a specific receptor that recognizes them. So we have a couple of others, including the B lymphocyte. It's an antigen-presenting cell. not just to remove the pathogens, but to break them down and present them, or tumor cells for that matter, cancer cells, and present them to the B and the T cells, okay? Anybody remember what reticular cells are? Not the reticulocytes we talked about with red blood cell development, but anybody remember from Bio 430 and the tissue description, when we were talking about connective tissue, we had reticular connective tissue. So, anybody remember what reticular cells really are?
Lymphatic.
We do find them in the lymphatic system, but they themselves are not blood cells. We'll get to them in just a moment. Here's a T cell. And it's impossible to determine in the blood unless a B cell has already been activated to be a plasma cell. That's usually not in the blood anyway, that's usually in connective tissue. So between a B cell here and a T cell, when we look at it in the blood and we're identifying lymphocytes, you can't tell the difference, all right, between a B cell and a T cell. If you have monoclonal antibodies and you were looking for surface proteins, you could, but as far as just identifying a lymphocyte, okay? B cells we can recognize after they've become activated, obviously, to the plasma cell. And so on Thursdays, when we're gonna talk about how antibodies are made, how T cells function, and cell-mediated immunity. But they're the ones providing the direct, specific immune response once they are triggered by a specific antigen. Macrophages, these are lysosomes, and so macrophages actually they have more than one nucleus. They have the pseudopodia that extend out and pull in the pathogens, and as I indicated earlier, they are one of our presenting cells, antigen-presenting cells. So reticular cells, and here we are looking in a lymph node. They are fibroblasts, and fibroblasts make collagen and elastic and reticular fibers. And reticular fibers are just a special type of collagen that we find in the lymphatic organs, such as the lymph node and the spleen. And the fibers, the collagen fibers, are actually covered and wrapped around by the thin fibroblasts. So reticular fiber is really a collagen fiber, bundle of collagen fibers with the fibroblasts wrapped around it. And their arrangement is such that it's short and branching, and it contains a sponge-like network of fibers that can support, if not, I suppose you could describe it as trapping the white blood cells and the macrophages, right? This is how we create that filtration system, where the lymphatic cells are not just moving along, being bumped by external forces. They're held within the space by the reticular fibers.
You said it traps the white blood cells?
Forms a fibrous network. All right, so as we talk about the lymphatic tissues and organs tonight, we're going to go in from simple to complex. All right, we're going to talk about diffuse lymphatic tissue, which is not an organ, it's not organized in the balls, it's just scattered. Concentration but scattered, if that makes sense. So closer together than you might just see in a typical loose irregular connective tissue, more highly concentrated than that, but not organized yet. Then we have the lymphatic follicles, which they're compact and held in spheres, but there's no capsule around the sphere. All right, so slightly more organized, but not yet encapsulated. So these two types that fuse the lymphatic follicles are found close to the surface, just deep to the epithelium in the loose, irregular, and dense irregular connective tissue of our digestive tract and respiratory tract primarily, all right, where there's a lot of exposure to pathogens in the air or pathogens in the food. So some of the locations, Peyer's patches we'll see in a moment, is where we have a high concentration. Tonsils are partially encapsulated. The appendix, again, a high concentration of them. And we have certain terms for some of those. So you'll notice I use the word follicle rather than the nodule I have in parentheses. I do that because we have an organized form called the lymph node we've talked about already. And in the course that I've taught for many years at Sac State, their lab manual actually had it wrong. And they called the follicles lymph nodes, not even lymph nodules. So to avoid that mistake, let's just use a different term. So we're not moving back and forth between nodes and nodules, we'll just use follicles for the ones that are not in a capsule. we start out with the least organized, and although it's not as diffuse as we see down here in the denser regular connective tissue, you're seeing mostly plasma cells here, although they don't have to be, they just are active with pathogens that have moved across the epithelium. So diffuse doesn't mean they're that scattered apart, just that they're not organized into spheres. Okay? So all these purple dots that you see here, these would be the villi of the intestines that I showed you in the model. These are all lymphocytes primarily. A few of them would be the nuclei of fibroblasts, but most of these purple dots are going to be the lymphocytes. And in fact, this white space here is probably a lacteal. They're wider in diameter than our typical blood capillaries. And we do have reticular fibers and loose irregular connective tissue. This is part of the normal tissue, so it's not having any specific function here, not as much as it has in the neck structure. So this is the Peyer's patches. This is a lymphatic follicle that we have right here. And lymphatic follicles are spheres of organized lymphocytes and some macrophages. So if we have, let me diagram a little bit of the small intestine. We have the villi, and we have intestinal glands. Now we can put in the lymphatic capillary here. Latch field. And so the diffuse lymphatic tissue would just be lymphocytes disorganized in this region, while the lymphatic follicle, it may be up close to the surface or it may be down here and deeper, is a sphere. So a round ball of much more condensed, many more closer together lymphocytes, okay? And you can see in some of those lymphatic follicles that the center area is lighter than the surrounding area. And that's because the center area contains plasma cells, okay? Anybody remember from a few minutes ago which of the lymphocytes develops into plasma cells? The B cells, all right? So, in the center of our lymphatic follicles is where we find the B cells, and out in the periphery is where we find the T cells. So when the B cells have been exposed to an antigen, that one or more of the antigens that one or more of them may be matching, they mature, differentiate into plasma cells. If we go back and look at this image of a plasma cell compared to a typical lymphocyte in the blood, notice how much extra cytoplasm. Our lymphocytes in the blood just had a clear rim, barely an edge of cytoplasm, and now there's a lot more cytoplasm typically than even the nucleus. So when we see that in the histology slide, it takes up more room, the extra cytoplasm. It's not staining nearly as dark as the nucleus. And so it makes that region appear lighter, okay? So a lymphatic follicle doesn't always have to have a terminal center. Often they do, and that just shows there are plasma cells that are present making antibodies, right? So this would be diffuse lymphatic tissue. And this would be a lymphatic follicle. Now, they may appear by themselves, all right, singly, 2 or 3 together. So the ileum is where we have them stuffed like this, 20 or more in a region. And the ileum is a special, it's the last section of the small intestine, just prior to the digested food entering into the large intestine. And it's normal for the large intestine to have bacteria. They have a symbiotic relationship, E. coli, all right? And so it makes sense that in case some of that bacteria backflows up into the small intestine where it doesn't belong, that we have a lot of defense cells to protect the ileum, okay? But it can occur just singly. So this is representing a single lymphatic follicle down in the deep connective tissue, but bulging up a little bit close to the surface. The colors are reversed. The darker color is in the center instead of the lighter color, all right? But to match the follicle, if you understand the reason why that those T cells don't develop into anything that looks different than that, histologically, it makes sense that the light regions are the B cells. So that's why they're, it's called the germinal center. It's not, it's where the new antibodies are being produced. All right, we also see in the appendix, it looks like the ileum. So if we were to look at that in the microscope, you would see a lot of lymphatic follicles in the appendix. And, it's been maybe 5 or 8 years that the theory was produced by a professor, scientist, I'm not sure if he's a medical doctor or not, in England, that the purpose of the appendix was to serve if somebody had a huge case of diarrhea and lost all their bacteria from flushing out of the digestive system, that it could be repopulated through the bacteria that are in the appendix. So it's kind of a bank vault of bacteria, of course. Although we populate it pretty easily when we're infants and we're born without any bacteria there, okay? So this would be the ileum right here, the last 8 feet or so, 8 or 9 feet of the small intestine emptying into the large intestine, so it's longer than what's shown here. So this is where we would find the Peyer's patches. And then the appendix would be a similar location of lots and lots of highly packed follicles. However, there's no organization other than the fact that they're packed close together. There's no capsule, okay? So we really couldn't consider it an organ, it's just a specialized region of tissue. And we're still seeing diffuse lymphatic tissue up here in the villi. Okay, so we're still in the small intestine. All right, so question number 3. So this is similar to what I showed you in the model of the small intestine where we have just one, although this is actually from the colon. So identify the type of lymphocyte found in the germinal center. You can probably see that light region easier towards the back of the room. It's closed up, but if you can't see it, it's this area right here. That would be the germinal center. Okay? If you can't figure out the answer, it's on the board.
B, right? B, I mean, B lymphatic. So A.
All right, so now we're going to move into a more organized arrangement of the lymphocytes. And we're going to start with the lymph node. While you're studying the models in histology, a long time before lymph node models were developed, but Jeff ordered these, I think, about 3 years ago. And so this is a lymph node. We have lymphatic vessels coming into it, and a few lymphatic vessels leaving. The area, so it's kind of like a bean, and it's probably about the size of a white bean or navy bean, kidney bean. And this is called the hilus here. So that's where the blood vessels come in, the arteries come in, and the veins leave. And that's also where lymphatics will leave. So the valves allow the flow into and out of, but not away from or back into the lymph node. So we have afferent lymphatics coming into the lymph node. A meaning going towards, if you remember the sensory system, nervous system. And we have efferent lymphatics carrying lymphatic fluid away. But those efferent lymphatics get to another lymph node the ones that are leaving are going to then flow into another one, and at that time, there's a bit of distance between them. They would be the afferent, okay? So they're not always only efferents. The efferents become afferents as they then flow into another lymph node. So the tissue fluid entering the lymph node is going to flow through multiple sets of lymph nodes, all for the purpose of getting filtered before that lymphatic fluid enters the blood. So I'm going to diagram, let you look at this on the board, and diagram a lymph node. So this is just showing where we find them. And again, they're grouped by region. So a lot of lymph nodes are found along the neck area. If you have a sore throat in the past, you've probably had swollen lymph nodes here, all right? And these are salivary glands, so if those are large and swollen, it's something else. Lymph nodes would be as well, but they're not. Lymph nodes are not as big as a salivary gland. But if you've had your teeth cleaned, I'm sure the dental hygienist palpated the area here just to check to see if there was any swelling. We have them along our major vessels and in the axillary area. So the mammary glands have a tail of tissue that lead up into that axillary area, and that's one of the most common sites for breast cancer to metastasize to. Okay, once it's moving out, the cells have separated from the primary tumor. They often are picked up by the lymphatic capillaries and would be transported to lymph nodes in this area more so than most other areas of lymph nodes around the mammary glands. So it used to be that any breast cancer was treated with a radical mastectomy, which meant not just removing the breast tissue, but removing all of the regional lymph nodes as well. And now a little bit more circumspect. If it hasn't spread to lymph nodes, they'll just do a lumpectomy, unless the woman just doesn't want to worry about it coming back, and she may request to have a radical mastectomy. And someone will have that done just because they know they carry the gene for it. Every single woman in their family has had breast cancer. They may just decide to go ahead and have it removed and have reconstructive surgery before they ever come down with it. So you can imagine that without those lymph nodes, there's going to be a disruption in the return of lymphatic fluid for that particular limb back to the heart. And that means there's increased edema. Okay? So usually for several months after surgery, the woman sleeps with her affected upper limb elevated to help with the drainage. And as we talked about, parasite in the lymph node, even without that surgery, can block lymphatic drainage. There's a particular worm, Filiaris, F-I-L-I-A-R-S-I-S, I think, filaria, that invades the lymph node and blocks the lymphatics, and that causes large swelling of the lower limbs because that's affected by gravitational flow as well, elephantiasis, or it can get into the scrotum, and the scrotum can be literally this large, okay? And so it can the lymphatics will redevelop, superficial veins do, but it takes a while for that to occur. All around the digestive system, obviously, and around joints like the inguinal region or the knee. So here's a diagram of a lymph node, along with an image of a histology. So the outer region, we'll use terms similar to what we use with the kidneys, is called the cortex. And it's in the cortex where we find the lymphatic follicles. So we're still working with follicles, balls of lymphocytes, all right? But now we have a capsule around it, a more organized pathway for which the afferent lymphatics are bringing lymphatic fluid. It percolates through or around the lymphatic follicles on its way out, and it repeats that through several different sets of follicles, all right? So let's diagram this. May I erase the diagram of the structures on the board? Okay. I'm going to do the capsule in black. It was in different color yesterday. So this capsule is what typical capsules are made up of. I want to regular connective tissue, like any capsule of an organ would have, and leading in, carrying fluid towards the lymph node. From previous lymph nodes or lymphatic capillaries, that's the first one in the system. And the valves are set to allow the flow into the lymph node. This will help you determine whether you're looking at an efferent or an afferent. So these are afferent. Okay, they're carrying lymphatic fluid towards the lymph node. Then we have some of the same connective tissue from the capsule extending down through the cortex towards the medulla, forming this into segments. And so these are identified as trabeculae. Now remember, we see our best organization of reticular fibers with our lymph nodes, all right? So I'll draw those in green after I put in the lymphatic follicles. So we're going to have the follicles in the cortex, which is essentially as far as the septi are formed. And I'm leaving a space between the follicles and the capsule. So we have room for fluid flow. And this would have the same organization as an isolated lymphatic follicle, where we have the B lymphocytes in the center and the T lymphocytes on that end. Okay? And so we're going to have reticular fibers spanning this space as well as spanning the flow channels.
Subcapillary segments.
I'll show you that in just a moment. We have two sets of, we actually have three different sinuses that we talk about. So between the capsule and the lymphatic follicle is the subcapsular. Let me switch the image so it takes up the entire screen. So this would be the subcapsular, okay? Which makes sense, sub meaning below or deep to. So just deep to the capsule, before it reaches the lymph nodes, the lymphatic follicles rather, would be our subcapsular, not scapular. The mouth wants to say scapular, but subcapsular sinus. All right, so that would be all the way along here. So the fluid comes in and can flow either direction through the subcapsular sinus.
In there is the
The reticular fibers, okay? And amongst the reticular fibers are going to be macrophages. And they're lying in wait for these pathogens that might happen to be carried in with the lymphatic fluid. So they're going to be, they can be in the follicles too, but they're easier to see and they have a better chance of function in the subcapsular sinuses or any of the sinuses. So the lymphatic fluid coming in from the afferent lymphatic will enter the subcapsular sinus, okay? And then it has two opportunities. It can either flow into a lymphatic follicle. So this would be one of our lymphatic follicles. Or it can flow around it and down towards the medulla along the trabeculae, and these are known as trabecular sinuses. Okay? So from the subcapsular sinus, can enter either the follicle itself, or it can enter a more free-flowing space, the trabecular sinus. So it can go into the lymphatic follicle. Or it can go into a trabecular sinus. And that's also spanned by reticular fibers. And the reticular fibers are in the lymphatic follicles too, but there's just a higher concentration of cells. All right, so it can either go along here and down the trabecular sinuses or through the follicle. So the trabecular sinuses are on either side of the trabeculae. That makes sense. And now it's in the medulla, okay? And the medulla still has concentrated regions of lymphocytes and sinuses, but now the concentrated regions of lymphocytes are not involved. They're in long cords. And these are primarily T cells. And they're formed to also create flow channels. This should be dots, not lines. I'm just getting lazy. So these would be the medullary cords. Okay, not a musical cord, just a cord, like a rope. And then the spaces between them would be the medullary sinuses. And that would also be spanned by reticular fibers. Again, this slows down the flow of the fluid and gives the macrophages a chance to come in contact with them and recognize, present any antigens it makes for the lymphocytes to recognize. So from the lymphatic follicle flow or the trabecular sinus flow, it's going to enter the medulla. And then it can flow through the medullary sinus, or through the medullary cord, and once it's done with that, it flows out the efferent lymphatic. Which would be here. And again, you can tell by the valve that it's going to allow flow to occur. Okay? So, in the afferent, along the subcapsular, down the trabecular, or through the actual lymphatic follicle, into the medulla, again through the medullary sinuses, or through the actual medullary cords, which are T cells. All right? So in the middle of the follicle, we have B lymphocytes. Out in the periphery, we have T lymphocytes, and in the medullary cords, we have T lymphocytes. With all the lymph nodes in the body, it's well equipped to overcome the occasional, or not so occasional pathogen, even a few tumor cells, all right? But if the tumor is aggressive and the cells are highly mitotic, it can overwhelm the ability of the lymph node tissue to take care of it. And it progresses from one lymph node to the next. So the lymph node rather is the only lymphatic organ or tissue to demonstrate afferent lymphatics. Our spleen, our tonsils, the thymus can have afferent lymphatics, but only the lymph node has afferent because it's in that system of sequential filtration. So you'll notice I've been giving characteristics of the different tissues and organs, and I'll continue to do so. So questions about these, well, we have two basic forms. If I give you, say, which of the following are characteristics of a lymph node, and then I list several, or I might list 2 or 3 characteristics and say, ask you to pick which one it describes, okay? So either give you the characteristics and you choose the tissue or organ, or I give you the tissue or organ and you pick the characteristics. So here's a better image even than what I show with reticular cells. These would be the lymphocytes and macrophages. Here's a reticular cell, and these are reticular fibers, the collagen wrapped around by the, so it spans even the sinuses. So any cell, bacteria that's kind of percolating through there is going to have to slow down as it bumps into these fibers, and that gives the macrophages a chance to attack them. All right, so that brings us to a partially encapsulated set of followers. These are known as the tonsils. Are you done with the diagram on the board? You're not going to get nearly so complicated with the tonsils, okay? So you kind of have the idea what follicles are now. I don't have to produce so many dots on the board. We find tonsils in 3 locations. The ones that are right behind the nasal, so that we call the throat, our anatomical term for throat is pharynx. And we'll talk about more when we get to the respiratory system and the digestive system, and there's 3 regions of the pharynx. So posterior to the nasal cavity is called the nasopharynx. Posterior to the oral cavity is called the oropharynx. And posterior to the voice box is called the laryngopharynx, all right? So we find our tonsils, there's one in the nasopharynx, and there are 2 pairs in the oropharynx. So they're associated with the epithelium of their location. This is a large tonsil that we find in the oropharynx. So what would be the epithelium lining the mouth? Anybody remember from biopressure? Stratified squamous, non-quantified, because quantified would be the skin. So the tonsils in the mouth would be their surface, because they're right up there in the surface of the digestive tube, would be non-quantified stratified squamous epithelium. So the ones you just saw are the palatine tonsils. When we get to the digestive tract, we'll name these 2 folds. They're actually formed of muscle that goes from the palate to the tongue and the palate to the throat. And then we have even a larger set of tonsils that form the posterior third of the tongue. So this is not a human tongue. I think it's cow, but I'm not sure for sure. Maybe wolf. The larynx has been cut open, so you can see the voice box. All right. Epiglottis there. And the palatine tonsils would be here on the side. And these 2 bumps are the lingual tonsils. Lingual means tongue. All right. So palatine and lingual are both paired. I'll let you pass this around. And they would be covered by the epithelium in this area, because anytime we have food, we have non-quantified stratified squamous through the mouth and down the esophagus until we get to the stomach. What's our respiratory epithelium? We have a whole bunch, but we have one that is given the name of respiratory epithelium. Yeah, pseudostratified columnar. It gets shorter and simpler, so we get simple columnar and simple cuboidal as we move deeper into the lungs. But the nasal cavity and the nasopharynx are lined with pseudostratified columnar. The nostrils aren't. And here would be the adenoids or nasopharyngeal tonsils. Those are not paired. And their epithelial covering is pseudostratified columnar. Okay? Because things were wrongly labeled, I had a hard time finding epithelium that had pseudostratified columnar. Because even if the histologist online was called adenoids, they showed it with non-quantified stratified. Like, no, that's not adenoid. So it took a lot of looking to find some with pseudostratified. The non-quantified was easy to find. So when we look at tonsils, they have particular characteristics, and the one that's the easiest to pick up on are the presence of tonsillar crypts. These deep infoldings, all right? So the tonsils are on the surface. You can see it right there. Any air or fluid flowing by is going to come in contact with their epithelia. So that's why the reason they don't have a capsule out there is because they have an epithelium, all right? And they have these deep infoldings or crypts. Find it black that actually works. And the surface that I've drawn would be the epithelial surface, okay? So any pathogen that's going to get across this has to pass between the cells. So nasopharyngeal, the nickname is adenoids. Is going to have pseudostratified, columnar. And I don't know if you remember the characteristics, but it's columnar cells that look like they have multiple levels of nuclei, but they actually, in fact, all the cells touch the basement membrane, and they always have cilia, all right? Now, we talked about pseudostratified in the male reproductive tract, which had the long microvilli. But as a respiratory epithelium, they're always going to have cilia. And if we're talking about the palatine tonsils, those are the ones to the side of your mouth, or the lingual tonsils. These are non-cornified, or you may be more familiar with the term non-keratinized, which is what skin is. Stratified squamous epithelium. All right? Then they're going to have follicles. So they're going to have follicles that we talked about with the same arrangement of B cells and T cells. And because they have epithelia on one surface, they do not have a connective tissue capsule there. Instead, the epithelial tissue capsule is deep. So it's going to separate the tonsil from the rest of the nasopharynx or from the rest of the mouth. So this is a partial capsule. It's pretty thick. It's for surgery, when they take the tonsils out, they use a little surgical apparatus, so it's a bit like a spoon. All right, it's pretty easy to scoop that out, and then just cauterize the blood vessels. Okay. So,
On the, towards the body, basically,
Right.
and the other.
yeah, the connective tissue, the tissue will be supplied with blood from underneath. So when the quote-unquote spoon scoops this out, it's going to be tearing those blood vessels along that border there. Now this would have efferent lymphatics, okay? So there would be efferent lymphatics present that would be leaving the capsule. Blood vessels going in and out. But because the surface is the skin, there would be no afferent. Okay. So E going away from. The presence of these crypts kind of directs bacteria in the food or the air towards the deeper areas, but it also serves as a trap. Right? So people that tend to get frequent sore throats often have their tonsils affected, and as a child, occasionally as an adult, may elect to have them removed. So palatine and nasopharyngeal tonsils are the ones more likely to be removed. I don't know the incidence anymore. A student of mine had had her lingual tonsils removed, and I've never heard of that. And she said she was the first one that her doctor had done. So it's not nearly as common, but it certainly can affect swallowing, okay? The palatine tonsils can affect swallowing, and the adenoids, I know my youngest son had his removed when he was about 14 months. And, he was already in recovery when I got to the hospital. I'd been at the school with my oldest son. He was getting some kind of an award, whatever you get when you're in first grade. And so Will was already in recovery, and the surgeon came to talk to us and asked if he snored when he slept. Both of us said, not that we noticed, and he said, well, under anesthesia, when he was relaxed and asleep, the adenoid, his nasopharyngeal tonsils completely blocked his airway through his nose. And so, you know, he probably snored as a mouth breather. The reason that they were taken out was because of his speech. Although at 14 months he wasn't saying a lot of words, but they couldn't figure out how much to take. They didn't know how it was affecting the blocking of speech, so whether it was too much or too little. But they only did the surgery once. And I remember being with him at a playground, and he'd say something, and other parents would look at me and say, what did he say? And I have no idea. And he saw a speech therapist for about 1.5 years down, and he went to school up here, about half a mile away, but we were living in Elk Grove, so we would drive him down to the Elk Grove School District. He called it the Batman School, because he got to play with Batman toys before his series. And he only did it for a couple years. You know, then now his speech is fine. In fact, we were told when he was born, because of the paralysis of the muscles forming a soft palate, that he wouldn't be able to say the hard G sounds or the hard C sounds like a cookie. And he either compensates very well, or it didn't affect them the way that they thought it would. Okay. So, nasopharyngeal up here, palatine, and lymphatic. All right. So, question number 4 is, we've got this tonsil here, all these little small dots, so this is much larger. All these little small dots under follicles, all right? So here would be the surface of that image. I can bring it down a little bit, but I wasn't given much of a choice. So your decision is, are you looking at non-quantified stratified squamous, or are you looking at pseudostratified columnar? This would be the end of the epithelia here. It's hard to see a separation from the connective tissue. Okay, let's go ahead and take a break here. We're going to talk about this spleen next. We'll cover